So this is the short lesson for rational exponents. Now what you need to remember is that they work like regular exponents. For example, if I take a look at this equation, 3 to the 1/2 times 3 to the 3/2, we end up with 3 to the 4/2. And the reason why that happens is because we have 1/2 plus 3/2 is going to equal 4/2, which eventually equals 2. And we would be able to do this for any type of rational exponent. So if we had a fractional exponent, a rational exponent, multiplied by another exponent which wasn't a fraction, all the rules that we used to do before would still apply. Now, let's get into the guts of what the lesson is all about. You know that from before, 3 squared is equal to 9 because that's 3 times 3. So that means the square root of 9 is 3. So if we have 4 squared, it's equal to 16. This means that the second root of 16 is equal to 4. Now you guys would sometimes call it a square root. So let's do that again. So if I have 5 squared, I got 25, which really means the square root of 25 is equal to 5. These are all things that we learned a long time ago. Just remember that some people in this world call this number here the square root, or they would also call it the second root of 25. So now let's look at other roots. So suppose I have 2 cubed equals 8. We would say that the third root of 8 is also equal to 2. So what we're saying is that it takes 2 times 2 times 2 to give us 8. Now we'll do this again. So now 3 cubed equals 27. So now we can say the third root of 27 is equal to 3. Similar, we can say 4 cubed is 64, which means the third root of 64 is equal to 4. Remember that the number that's just sitting in front of the root sign says we need a number multiplied by itself 3 times. That gives us the number underneath the root sign. In this case, it's 8. So 2 times 2 times 2 would give us 8. The same could be said for 3 times 3 times 3, which gives us 27, and the same could be said for 4. Now, the gist of today's lesson is to talk about rational exponents. When we talk about rational exponents, we're really talking about not rationals, we're talking about fractionals. Now, these exponents that we're going to be looking for are going to look similar to these. Now, we're going to continue using those same roots that we were using before. So, I'm going to rewrite each of these equations as an alternate form. But this time we're going to write every one of these ones here, the third root of whatever, as a fractional exponent. So now we've got our first equivalence. So what I'm trying to tell you is the third root of 8 could be written as 8 to the 1/3. Now you'll notice I have two different numbers, one in purple and the 3 in blue. We're going to go and write an alternate way of writing this expression, which is equivalent to this. To do this problem, we're going to have everything equal to, well, I'm going to have a square root sign and an 8. Now, remember that 3 that was in the denominator of our fraction? We put that all in brackets, and then we raise it to the exponent number that we had before. That was on our numerator of our equation. So notice the numerator goes on the outside of this bracket, and this, the denominator, forces a root. And in fact, it says, take the third root of 8, calculate that, and then raise it to the power 1. So let's do that for these next 3. So if I was taking a look at the third root of 27, let's go and rewrite this in something that we can understand. That's similar to what we just did. So if I wrote 27 to the 1/3, we write that as, well, we're going to put 27 underneath the root sign. Now, the denominator, the 3 that's on the bottom of the fraction, goes with the root, and the 1 goes up here. Let's do that again, this time for 64. So we're going to go 64 to the 1/3 is the same as, well, the third root of 64 in brackets raised to the power of 1. You'll notice that the numerator of this always goes to the outside. So in general, if I had something, let's call it big A to the n over m, we would write this as the mth root of big A all raised to the n. Now that leads to some new problems. So we'll try the following. So if I have 64 to the 4/3, I'm going to write this as the third root of 64 all raised to the 4. Simplifying, we get, simplify the inside, we get 4. Make sure you leave your bracket around your result raised to the power of 4, which ends up as 256. Now let's do the next one. 27 over 64 raised to the -2/3. So now let's apply our rules again. So we had a negative exponent, so that meant we had to flip our fraction and remove the minus sign. Now let's apply the 2/3 to the top and the bottom, just like we used to do before. And we get this. Now let's apply our rules to each of the individual numbers based on our rule that we just calculated. Now simplifying the top and the bottom inside parts, we're going to get this. And we get, as our final answer, 16/9. And we're done. Now your homework is basically the worksheet that I gave you, and I need you to do all 4 pages for this assignment. Okay, have a good day.